right, we've got another great question here. This is a 2018 number 5, so it is non-calculator, and it is not in your notebook, so you'll need to either print it out or copy it down for yourself. During a chemical reaction, F of t models the amount of a substance in grams at time t seconds. At t equals 0, there are 10 grams, so we should highlight that, of course, as our initial condition. And they give us this differential equation. So part A, I hope, is fairly obvious using a tangent line. So write the equation of a tangent line at the point 0, 10, and then approximate it at 2. So I'm just going to go ahead, let me flip this, and start my tangent line. Y minus y1 equals m times x minus x1. And now I'm quickly just going to change the variables. Instead of dy dx, it says dy dt. So y minus y1 equals m times t minus t sub 1. And I'll plug in that initial condition, 0, 10. Sorry. Y minus 10 equals m times t minus 0. And then I'll need the slope, of course. So figuring out the slope is very simple. And the reason it's so simple is because we already have the function for slope in front of us. Right here, they tell us the slope, so we just have to plug in our value of 10. So off to the side, dy dt equals negative 0.02, and I'm going to plug in that 10 squared. Now, if the negative 0.02 kind of freaks you out, A, don't let it because you're going to be able to use your calculator, and B, what I usually do is write it as a fraction for myself. So this is read 2/100ths, so I just call that 2 over 100. Shucks, and there was a negative there. So negative 2 over 100, and then 10 squared is just 100. So I just get negative 2 as my slope. But don't forget, you do get a calculator on this year's exam, so don't worry about those decimals. And now I just have to approximate a time t equals 2. So I've got y minus 10 equals, that's a negative 4. Add that over, I've got y equals 6. All right, scrolling on here. Part B. So we haven't exactly seen this question before, but I think it's easy to talk through. So using the given differential, determine whether the graph of f could resemble the following function here. So let's think about the one thing they gave us. The only thing they gave us is that differential equation. So let me jot that down again. Dy dt equals negative 0.02, is it y squared? Okay. So now let's think about what that means. Dy dt represents the slope. So really, the only thing we know is the slope here. And then I kind of have to compare what I know about that to this graph. All right, so now let's keep talking to ourselves. This function represents slope. Now I can take any number I want for y and substitute it in. Yeah, I can. And whatever I do to that y value, I'm going to square. So if I take that y value and square it, this is always going to become positive. And then I'm always multiplying by a negative 0.02. So a negative 0.02 times a positive should always be a, oh, that was disgusting, negative. So if my slope is negative, that tells me that my graph should always be decreasing. So if I take a look at this function, you'll notice that it's decreasing, but then it starts to increase. So my answer is going to be no right away because this function should always be decreasing.